So the question is the greatest term in the expansion of root 3. Question number 13. Greatest term in the expansion of root 3 of 1 plus 1 upon root 3 to the power 20. Right. So what you can do, you can find the maximum term, greatest term in the expansion of this, and you just multiply by root 3, and that will be the answer. Right. So in order to do so, let's say tr plus 1 is the greatest term, right? If tr plus 1 is the greatest term, then of course tr is going to be less than that. Okay, so you can write it like this: tr plus 1 upon tr is greater than 1. Now what is tr plus 1? Tr plus 1 is ncr 1 to the power n minus r, and 1 upon root 3 to the power r, and this is going to be tr. Tr is ncn minus this can be written as tr can be written as tr minus 1 plus 1. So that is going to be nc r minus 1 and 1 upon n minus r plus 1 and 1 upon root 3 to the power n minus r. Sorry, r minus 1. Okay. Now what is the value of n? N is 21. Okay, the total the n is 21. So this is how you can write it, or you just don't substitute the values of n for now, you do it later. Now this is going to be 1 and this is greater than 1, so ncr can be written as n factorial upon r factorial upon n minus r factorial. This divided by n factorial upon r minus 1 factorial and n minus r plus 1 factorial. And now bases are same, 1 upon root 3, 1 upon root 3, so power gets subtracted. So 1 upon root 3 to the power r minus r plus 1, that should be greater than this. So this is going to be equals to this is going to be this. Okay, so we are talking about this expansion of this thing, this term. Okay, now n factorial will cancel out with this one. Now what is remaining? So this is going to be r minus 1 factorial and n minus r plus 1 factorial. Okay, upon this is going to be r factorial and n minus r factorial. Okay, and that's going to be greater than, this is 1 upon root 3 is greater than 1. Okay, so what you can do now, you just expand this and express this from here. Okay, so if you do so, you are going to get this r minus 1 factorial n minus r plus 1 into n minus r factorial, and here it is r into r minus 1 factorial into n minus r factorial. So this is cancelled out in with this with this, and this is remaining with 1 upon root 3 is greater than this. Now how can you do this? Now n minus r plus 1 upon r into 1 upon root 3 is greater than 1. So what is the value of n? N is 20. So 20 plus 1, 21. So 21 minus r upon r root 3. Okay, so that should be greater than 1. Now you cannot do cross multiplication in inequalities, so you have to take one from right hand side to left hand side and you have to subtract them. So 21 minus r root 3 upon r root 3, that is what we are going to get. Okay, so this is greater than 0. So what this implies? This implies this 21 minus r, if you take r as a common, so it is going to be 1 plus root 3 upon r root 3, so that should be greater than 0. So this inequalities hold if r is greater than 3, r root 3 is greater than 3, and at the same time 21 minus r plus 21 minus r into 1 plus root 3 is going to be greater than 0. Okay, yeah, if both are going to be positive, that only when this term is going to be positive. So for this, if you evaluate it, it is going to be r is less than 21 upon 1 plus root 3. Okay, if you rationalize this, it is going to be 1 upon root 3, 1 minus root 3, like something like this. Okay, and if you evaluate this term, this is going to be 21 or so better is you do it like this, root 3 minus 1. Okay, so that will not affect, just for the simplification purpose. So root 3 minus 1 is root 3 upon 2, so 21 upon 2 into root 3 minus 1 is 0.7. 73. So if you calculate it, I guess you do it by yourself, right? So I guess it is going to be something greater than 7. Okay, so r is, it means this term is something greater than 7. So just less than, just 7 point something, just lesser value, r is just less than that. So integral value of this is going to be 7. So r is going to be 7, right? So you try to solve it by yourself. I have done it, and it is going to be less than, it is going to be less than 7, I guess. Means r is going to be 7, right? So t r plus 1, that is t 7 plus 1 is going to be the greatest term, right? And if you evaluate it, what it is going to be, t 7 plus 1 is nothing but 20c7, and 1 to the power anything is going to be the same, and it is going to be 1 upon root 3 to the power 7. And this is for the 1 plus 1 upon root 3 to the power 20. Okay, so root 3 is there also. Okay, so you have to multiply it with root 3 as well, right? So this is going to be 20c7, and 1 upon root 3 to the power 7 is going to be something like this: 1 upon root 3 to the power 6 into 1 upon root 3 into root 3. Okay, so root 3 will cancel out with root 3, and this is how you can do this: 20c7 upon 3 to the power 3. You evaluate it, what is after calculation, what you get is the answer. Okay, so this is how you can do this. Question number 13. Okay. Now the next question is question number 14. So the question is like this: if 1 plus x to the power 15 is written as c0 plus c1x plus c2x plus c3x square, and so on, I guess c0, c1x, c2x square and c3x cube, and so on, c15h to the power 15. So they want us to calculate the value of c2. Of course, c2 means 15c2 plus 2 into c3 plus 3 into c4 plus and so on 14 c15, right? So I have to calculate this. Now if I generalize this, I can write it like this: summation r minus 1, something like this, right? R minus 1, and here n is there for all the combinational terms. Okay, and here I can write it like r. Okay, so now if I solve it, like the value of r from 2 to where till what value I have to go, it is 15, right? So it should be 15. It should be 15. So our value of r is from 2 to 15, and if it is 2, then I am going to get 1. If it is 3, then I am going to get 2. So this is how, this is what I have to evaluate. Okay. Now if I separate them, means if I multiply them, I am going to get this: r equals to 2 till 15, and if I multiply them, r into NCR minus NCR. Okay, so this is what I get. Now just separate them. If I separate them, I'm going to get this: r equals to 2, r from 2 to 15, r into NCR. Now separate them. It is going to be r, value of r from 2 to 15, and minus NC, means NCR, just NCR. Okay, you got it. Now what you can do, see here. Now you know that there is a property, or you can say formula: NCR is equals to n upon r into n minus 1 CR minus 1. Okay, and this you can further break as like this: n minus 1 upon r minus 1, n minus 2 c, n minus 2 c r minus 2, like this. This is how you can write it. Okay, this can be written as this, and this further by using this you can also write this as this. Okay, so this is what you can do this. Now summation from r2 to 15, this can be written as r into n upon r, right? And this is going to be n minus 1 c r minus 1. Please pay attention over here. So this you can write. Okay, now see, you have a formula for this also. So point 1, and other point is summation from r equals to 0 to n, for 0 to n, NCR the formula is 2 to the power n. You know that NCR represents coefficients, right? So sum of coefficient, it is basically sum of coefficient. If you put here 1 plus x as 1, it is going to be c naught c1 x c, this is all, right? So you know that. So this is actually equals to the power n, but the only thing here it should start from 0, but here it is starting from 2. So in order to make it so, what I can do is I am adding what is the value of n over here? It is 15, right? So I can replace this by 15 because n is 15 over here, right? Okay. Now if I do this 15c0 plus 15c1, right, in this term, and I subtract it as well, right? I'm adding it and I'm subtracting it as well. If I add them and then subtract them, so what I'm gonna get, this whole term can be replaced by, right? So this whole term can be replaced by summation from r equals to, and one more thing, I'm doing it inside of this minus bracket. Okay, so remember this, r 0 to 15. I can write it like this, right? Because these terms were starting from 2, and I'm included 0 and 1 as well. Okay, so this whole thing can be written as 15c r. Okay, now this, and now this minus and this is going to be added, and this is going to be subtracted, but because of this minus, or you can say, you can leave it like this as for now. Now this is going to be 15c0, which is 1, and 15c15 is 15. So the overall value is going to be 16. Why? Because these are going to be added, and because of this minus. Now this r is going to be cancelled out with this, and this n is constant. Okay, except the limit, means if you are putting a limit from r equals to 2. Okay, so r equals to 2, and means limit is only on the r, right? So except r, everything is treated as a constant, so n is going to be outside. So n summation from r equals to 2 to 15. Okay, so this is going to be n minus 1 c r minus 1. So this is how you can do this. Now if you take it like this, r minus 1. Okay, so we are done with this, and we are solving this now. Okay, so what I can do about this? Now see, if I put r equals to 2, so what is it is going to be 2 minus 1. Okay, so it is going to be 2 minus 1, which is 1. So what is n? N is 15. So n is going to be 15, and from here now n minus 1 c r minus 1. So n is what? N is 14. Oh, sorry, 15. So this is going to be 15. 15 minus 1, 14. So 15 r equals to 2 means 15 till 15 r equals to 2, and this is going to be 14 c r minus 1, right? So remember that if you put r equals to 15 over here, so it is going to be 14, right? So it is not going like r is greater than n. This will not happen. Okay, so if you put this, so I will tell you later. So now this, and this is what? This is going to be 2 to the power 15. So minus 2 to the power 15 and minus 60. Now again, so for this term only, right? So for this term, this can be written as like this: 15 multiplied with means you can write it directly, but just for the simplification purpose, I am expanding it. So this is how it will be. Now 2, if you substitute 2 over here, it is going to be 14c1. Now if you substitute 3 over here, it is going to be 14c2 plus and so on. It is going to be 14c14, right? If you put r equals to 15, right? And this is going to be minus 2 to the power 15 and minus 16. Well, it is going to be inside, and it is going to be positive, right? Please pay attention over here. So what I have done is this. I have expanded it just for the simplification purpose. You will understand it, right? So this is how you can do this till now. Okay. You rewind the video if you have any confusion. It is going to be okay. Now, so I'm just rubbing the upper part. Okay. So now this. Now see, if it start from 14c0, right? So directly by using this formula, if it start from 0, it is not starting from 1, it is starting from sorry, it is starting from 1, not 0. So if it starts from 0, so like this, nc0, nc1, and so on, nc n, it is going to be 2 to the power n, but it is not starting with 0. So what we can do is we can add 14c0 and subtract it as well. So I can write like this, 15 multiplied with 14c0, it is not here but I am writing it, 14c1, 14c2, and so on, 14c14, and now I am going to subtract it, this one, because I have added it additionally, so I am going to subtract it, it is going to be 14c0, right, and minus 2 to the power 15 plus 16, right, so this is what it will become, right. Now this whole term, this from here to here, it is going to be 15 into 2 to the power 14 by using this formula, right, and minus 14c0 is just minus 1, minus 2 to the power 15 plus 16, okay. Now if I multiply this, minus 15 plus 16 means just it is simplification now, 15 into 2 to the power 14 minus 15 and plus 16, right. So I guess this is what you are going to get. It should be 15 into this, minus 15 plus 6, minus 2 to the power 15 and plus 16, right. So this 16 will cancel out with this, and if I take 2 to the power 14 as a common, so it is going to be 15 and it is going to be 2, right, plus 1, I guess this, is it so, 15 into 2 to the power 14 minus 2 to the power 15. So if I take 2 to the power 14 as a common, this is going to be 15 and this is going to be 2. Yeah. Now minus 15 plus 16 is going to be plus 1. So it is going to be 13, right? So it is 2 to the 13 into 2 to the power 14 plus 1. Which is an option of this. Yes, 13 into 2 to the power 14 plus 1. So option B is your answer. That's that. Right, so this is how you have to do this. So the various concepts, and one more thing, this type of formula which I have not taught you in the theory part will cover in this duration while we are solving the questions. Okay, so this is how you can do this. Now the next question is question number 15, right? So question number 15 is a little bit you can say lengthy, and you can, if you try, you can do it by yourself. So I am just going to you something kind of. Now this expansion can be written as whatever it is, 1 upon 2 plus root 3x plus 1 upon 2 to the whole power 7, right, and minus 1 upon 2 minus root 3x plus 1 upon 2 to the power 7 into this, right. So I have to evaluate this, and the polynomial we get, depending on what polynomial I get, I have to find out the degree, right. So just for the simplification purpose, let's say it is a and let's say it is b. So what I have to evaluate, a plus b to the power 7 and minus a minus b to the power 7. Okay, so I'm just doing so. Now this can be written as 7c0 a to the power 7 and b to the power 0 plus 7c1 a to the power 6 b to the power 1 plus and so on, right. And the last time is going to be 7c7 a to the power 0 and b to the power 7, right. And I have to subtract it with this. Now see, 7c0, the first term is going to be same, 7c0 a to the power 7 and b to the power 0, but the second term is going to be negative. Why? Because it is going to be 7c1 a to the power 7 and minus b. Here it will be minus b. So let's say like this, minus b to the power 1. Because of this minus, this term is going to be negative, right. And similarly for it is going to be 7c2 a to the power, this is 6, right, this is 6. So 7c2 a to the power it is going to be 5 and it is going to be minus b to the power 2, right. So this is how it will go. Now the next term is going to be negative, right? You know that why it is negative, and so on. And the last term is 7c7 a to the power 0 but minus b to the power 7, something like this. Okay, so this while we are subtracting, this term will cancel out with this one, okay, and this will remains this one, right? And similarly, first, third, fifth, seventh, total 8 term will be there, but first, third, fifth, seventh term will cancel out. This is the first term, and the other one will have the power, this means the third term, this, right? It is going to be positive, but it is positive, but because of this minus sign, they will cancel out. So the terms that will remain is second, fourth, sixth, and eighth. There will be 8 term in this extension, right? Because the power is odd, means 7. So the total number of terms in the expansion of a plus b to the power n is n plus 1. Now, so for this evaluation, what we are getting is 7c1. Now a to the power 6, b to the power 1, right? And here both are going to be same. So I am going to put a double over here. So you know that, right? Because this and this is going to be the same. So these 4 terms will be repeated. So that is why. Now the next term is 7c3 a to the power 6 and b to the power 3. Not 6, it is 4. Similarly, 7c5 a to the power 2 and b to the power 5. And the next term is 7c7 and a to the power 0 and b to the power 7, right? And here it is going to be, so this is what it is going to be, right? Now substitute the values of this a and b, or you can take b as a common, right? So this multiplied with 1 upon root 3x plus 1. If I take b as a common, so what is going to be, right? So please see here. So if I take b as a common, so here b is going to be, and the powers are going to be decreased 2. Here it is going to be 4, and here it is going to be 6, right? Now I have taken b as a common, right? And what is b? b is nothing but root 3x plus 1 upon 2. So this will cancel out with this, and this 2 will cancel out with this. So in the last, what I am remaining with 7c1 a to the power 6 plus 7c3 a to the power 4 b to the power 2 plus 7c5 a to the power 2 b to the power 4 and 7c7 a to the power 0 and b to the power 6, right? So overall a is not going to contribute in the degree because it is a constant, so only b will contribute, right? So b. Now the maximum power is going to be for b to the power 6. This will give us this to the power 6, so I am going to get this 3x plus 1 means root 3x plus 1 upon 6 by 2. So this is equivalent to 3x plus 1 whole cube divided by 2. So what could be the degree? Degree is going to be 3. So the answer should be 3. So this is how you can do this. Okay, so try to avoid this thing, right? Because if you are writing these terms instead of a and b, so the calculation is going to be hectic and complex as well. So you can do it like this. Okay. And by practice, if you have proper practice of binomial theorem, so you can directly think of it like which term is going to be cancelled out and which term is going to be remain. So you can directly come up with that step, right? So like first term, third term, fifth term, like these terms are going to be remain or not, right? Next is 16. So question number 16 is very simple. They are saying that 1 upon x plus 2x to the power 6. So they are saying that's the sum of the coefficient in the binomial expansion of this. Okay, so every time if you have to find the sum of the coefficient, so then you just have to put x equals to 1. So if you put x equals to 1 plus 3 to the power, 1 plus 2, because x is going to be this is so 3 to the power 6. So what is the 3 to the power 6? 3 to the power 6 is I guess 729, maybe. Oh, you know that 3 to the power 6 is 3 3 is 9, 3 and 9 9 is 81, 81 9 is 729. Yes, it is, right? Now next question. So next question is 17, right? So 15c0 and 5c5 plus 15c1 5c4 plus 15c2 5c3, and I guess it is going to 15c0 1 2 and 5 4 3 2 and 1. So 15c3 5c4 2, 15C4, 5C1. So this is how it is, right? So what you can write about it, this can be written in terms of summation. The value of R is going to be from 0 to 4, right? 15C, this is I, or R you can write it, and it is going to be 5C, 5 minus R. This is how you can write it. No, it is not. It is going to be 4, yeah. Okay, so this is how you can do this. The thing is very simple. If you add these two, so the total terms is always going to be 5, I guess. 0 plus 5, 5, 1 plus 4, 5, 2 plus 3, 5, 3 plus 2, 5, 4 plus 1 is 5. Okay, so so what you can do, you can think of it like this. There is two group, one containing 15 and other containing 5 elements. Okay, and you have to choose 5 elements, right? So what is the possibilities? Okay, means you have to take 5, means these two are the groups and each having the distinct element, so you have to select 5. So what is the total possibility? You can have 0 element from this group and all 5 from here, right? So like this. Or you can have 1 element from here, 4 element here, 2 element from here, 3 element from here, 3 element from here, 2 element, 4 element. Just one thing is missing. It is possible that you can get 5 from here and nothing from here, right? So just to make it like this, because it is generally basically it is a question from permutation and combination. Okay, so you have to select 5 objects. So how do you know that 15C0 and 5C0 means out of 15 I am going to get 0 elements, and from 5 I am getting all the 5 elements, right? So this is how you can think of it. Now, but here it is saying that in the last it is so overall 5. So if I take it like this, means I consider all the possible combination of getting 5 elements. So how I can do this? So I'm just putting it over 5 over here, right? 15C0, and I'm just subtracting, right? Because at 5 means 15C5 and 5C 5 minus 5 is 0. So I am getting subtracting this. Why? Because it is basically from 0 to 4 and I have added the 5th element. That is why I have to subtract that. You get this? So basically for 4 means like this. So I have basically added this 15C5 and 5C0 and subtracted it as well, 5C0, right? So this whole term now become this, right? And this is separated, right? So now this can be directly this term can be written down directly. So what I can write about it, 15C0 about this and 5C this, 15C5 minus this. So this is basically just the selection, right? So so this can be directly written as 15. So what you are going to get? So you have 15 element from here and 5 element from here. Okay, and you have to choose 5 element from overall, right? So it is something like, and they all are different. So it is something means you have total overall 20 choices and you have to pick 5 from them, right? So this whole thing can be written as 20C 5, right? So you getting this? So 15C R means you have 15 a group of 15 objects and all are distinct, and you have to select and 5 others, and overall you have to select 5 elements. So what are the possibilities? This could be the possibilities, and this is how you can write it. So if I take it as a total, because all are distinct, so from 20 I have to select 5. So this is what it becomes. So 20C5 and minus 15C5, because 5C0 is 1, so 15C5. So this is going to be 20 factorial, 15 factorial and 5 factorial minus 15 factorial upon 5 factorial and 10 factorial, 15 factorial. So this is how you can do this. So you can remember it in this way. So this becomes generally a formula, summation from R equals to 0 to minimum, right? Minimum of m comma n. So it could be anything, right? Or considering that m is minimum, so this can be written as nc R, and it is going to be MC M minus R, right? So so this can be written as M plus N C M, minimum of M comma N is M, right? So this is how you can remember it. Okay, and the concept is very simple, and concept is this, right? So 15 and 5 are the two different groups of elements having this, they are basically distinct, and if I combine them, this is going to be 15 plus 5, 20. So 20 element, and you have to select the 5, so 20C5 directly. Okay, so this is how you can do this. This was the question number 17, and next is question number 18. So the question number 18 is the coefficient of x to the power 5 in the expansion of this. So 1 plus x square to the power, this is question number 18, to the power 5, and 1 plus x to the power 4. So what I have to do is I have to find the coefficient of x to the power 5. So the best thing is just to expand it, right? So if I expand it, it is going to be 5c0. I am not writing it like in the formula basis. I am writing directly. You can understand that. Right, so it is going to be 5c1, that is 5c1, and x to square to the power 1 plus 5c2. I have to find the coefficient of x to the power 5, right? So 5c2, x to the power 2 to the power 2 plus 5c3, and x square to the power 3, and so on. This is what it will be, and from here it is going to be multiplied with 4, right? So 4c0 plus 4c1x plus 4c2x square plus 4c3x cube plus 4c4x to the power 4. So this is what it becomes, right? Now I have to find the coefficient of x to the power 5. So this should multiply with something with the coefficient of x to the power 5, but there is nothing, no term with having the power exponent of x as a 5. So this will be discarded. Now this x square. So if this term multiplied with x to the power 3, then I am going to get x to the power 5, and it will give us a coefficient. So this will multiply with this, so 5c1 into 4c3 becomes x to the power 5, right? So this is 1. Now this is x to the power 4, x square to the power 2, x to the power 4. So if this multiplies the term x, then I am going to get the coefficient at x to the power 5. So it's going to be 5 to the power 5c2, and it is going to be 4c1, and x to the power 5, 4 from here, 1 from here. Now it is x to the power 6. So in order to get x to the power 5 here, it should be x to the power minus 1, but there is no term at all, right? So this, for further we can't do this. Okay, so so this is going to be this. So x to the power 5, I take it as common, so it's going to be 5 into 4 plus 5c2 is 10, 5 to 5c2, 5 4 22, 10, yes, into 4. So the answer should be 40 plus 20, 60, right? So this is how you can do this. Next case, take the coefficient of x to the power minus 4, and the next is question number 19. They are saying that if the coefficient of x to the power minus 2 and minus 4 in the expansion of this are m and n respectively, then find the value of this. Okay, so let's say tr plus 1 is the term that having the coefficient of x to the power minus 2 for the first term. So it is going to be ncr, and x to the power 1 by 3 to the whole power n minus r, and 1 upon 2x to the power 1 by 3 to the whole power r, right? So okay, now this can be written as, what is n? N is 18, so this is 18cr. Now x to the power, here we said it, 8 minus r by 3, you got it, right? N minus r, because the powers will get multiplied like this. Now this is going to be 1 upon 2 to the power r, and this is going to be x to the power minus r by 3. Okay, so this is the basic system. I think you know that, right? So now this and this will multiply it, and what it becomes, x to the power 18 minus r by 3 minus r by 3. Base and power will get added. Why it is minus r by 3? You know that. Now this should be minus 2, right? This should be minus 2 for the first term. For the first term, it should be minus 2, and same thing should be minus 4 for the second term. So you have to just simplify it. It is going to be 18 minus 2r by 3. Once it should be minus 2, and 18 minus 2r upon 3, again it is going to be minus 4. You get the values of r from here. So if I substitute r equals to, means if I solve it, it is going to be 2r is equals to 24, I guess. 3 minus 2, 6, 24, yes. So r is going to be 12. And from here, if I solve it, it is going to be 2r is equals to 3 4 is 12 and 30. So r is going to be 15, right? So for r equals to 12, whatever I get, it is going to be m. The coefficient is going to be m. So what is it is? What it is? 18c, r is 12. And here it is going to be this will be discarded, and it is going to be 1 upon 2 to the power r. And what is r? R is 12, right? And from here, whatever I get, and what I get, it is going to be 18c 15 into 1 upon 2 to the power 15. So this is going to be m, and this is going to be n. I think you are getting this, right? So so you know that. So 18cr is this means this term you are familiar with this. It is just a general term, and in order to get the coefficient of x to the power minus 2, I have to separate x, or the terms of x, right? So I'm just simplified this, and I have separated 2 because it is a constant. And now after these two multiply, the power bases are same as x, and the powers get added. So it is going to be this, right? Now this whole term is minus 2, right? Because I am interested to find the power of x to the power minus 2. That is why. So this term is going to be minus 2 for once, and for the next I also want to find the coefficient of x to the power minus 4, right? So this will be substituted by minus 4 as well. Now for this r is 12, and for this r is 15. So what is the coefficient? So coefficients are this for both terms, right? So for m, when you substitute r equals to 12, you are going to get m, and when you substitute r equals to 15, you are going to get n, right? So if you divide them, because in last they have asked you to find m by n, so what it is? So 2 to the power 15 will cancel out with this, so it is going to be 2 to the power 3 actually in the numerator basically, right? And 18c12 and 18c15, you solve it. So it is going to be 18 upon 12 means factorial, and 18 minus 12 is 6 factorial. Similarly, 18 factorial, 15 factorial, and 3 factorial. It will be cancelled out with this, and this is going to be like this: 2 to the power 3 into 15 factorial, 3 factorial, and upon 12 factorial, and 6 factorial. So how can you write it? This can be written as 15 into 14 into 13. This will cancel out. This can be written as 6 into 5 into 4 into 3 factorial will cancel out by this, right? So the answer should be something like this. 6 5s are 30, 6 5s are 13, 15. This is going to be 2. Now 2 will cancel out with this. This is going to be 7. So 7 into 30, 91. And this is going to be, I guess, 4 only. And here it is 8. So it will cancel out with this as well. So 91 into 2. Wow, 182, right? So this is going to be question option number B. So this is how you can do this. This was the question number 19. Okay, this was the 19. Now the next is the last one, right? We have already done this type of question. So basically for this you have to just observe the pattern for the power of 3, right? Generally the questions are done in the same way. You have to follow some pattern. Means for that, like they have asked you to find the 3 to the power 104, I guess 101 plus 1, and what will be the last digit in this, right? So 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27, 3 to the power 4 is 81, and 3 to the power 5 is 243. So after this, they all will have a unit place. Means 3 to the power 6 will have a unit place at unit place of 9. 3 to the power 7 have 27, right? So after the period of 4, they repeat themselves, right? Means everything which is a multiple of 4n is always going to have 1 at unit place, right? So you just basically divide it. So it is going to be 3 to the power 100 into 3. So 3 to the power 100 will have 1 at unit place, 1 at unit place. And now if you multiply it with 3, then the whole term is going to be have 3 at unit place. And if you are adding some 1 with 3 at a unit place, so the overall it is going to be 4. So this is the answer. So this is how you can do this. Okay.